So today we're going to look at some applications of scale drawings and scale copies in real life. And one of the most common we use is maps. So here's a screenshot of a map of Sofia. And you'll notice in the bottom right-hand corner, we have a scale. And it tells us for a particular distance on the map, that distance represents 500 meters in real life. And the reason this scale is important is because if we change the perspective on the map, now the same amount of distance is representing 2 kilometers in real life. So each map will have a unique scale based on how much distance we're trying to show. So now let's look at how we can use proportions to solve problems about scale drawings and maps. So let's say we have a map and we have a scale where 2 centimeters represents 25 kilometers in real life. So first question, how many kilometers would be represented by 10 centimeters on the map? So remember that when we set up our proportion, we need to be consistent. So I'm going to decide that I'm always going to put the map distance over the real life distance when I write my proportion. I'm going to go ahead and start with the scale that I know. I know that 2 centimeters on the map is equal to 25 kilometers in real life. So I've set up my first ratio comparing map to real distance. Now I'm going to make a second ratio, and based on the information, what I have is the distance on the map. So that's going to go on top because I've decided that the map distance is always going to be the top of the ratio. You could do this the other way. All that matters is that you are consistent. And here we are, we're looking for x, which will be the distance in real life. Now, this is one of those proportions where I can just use my number sense to find the missing number. I can see that 2 times 5 equals 10, which means the real life distance also needs to be multiplied by 5, which is 125. So I know that 125 kilometers would be represented, or 10 centimeters, on the map. Now the second question says, if Plovdiv is 140 kilometers from Sofia, how far apart would they be on a map? So we're in centimeters, so this question is asking how many centimeters apart would they be on a map with this scale. So similarly to what I did before, I'm going to set up a proportion. I'm choosing again to compare map distance to real distance, and I'm going to take my scale and make my first ratio. So your given scale should always be your first ratio. And then the second ratio will have one piece of information that I know, that Plovdiv is 140 kilometers from Sofia, and a piece of information I'm looking for. How many centimeters will we need to represent that distance on the map? And this would be a good opportunity to use cross products to solve the proportion. So I know that 2 times 140 is 280, and that should equal 25 times x. And then I'm going to solve for x by dividing by 25. So a reminder that even if you're using a calculator, you still need to show your process here so that someone looking at your work can see where your solution came from. So let's do 280 divided by 25, and I get 11.2. So 11.2 centimeters on the map would represent 140 kilometers. I'm going to make sure that I answer the question with units. Other times we see scale copies at work in real life are where we want to take a large object and reproduce it in a smaller size, but with the measurements being in proportion. So for example, if we want to make a model of a car or a train or an airplane, or when architects create a blueprint for a building, all of the measurements must be to scale for the actual building to turn out correctly. All right, so let's say here we have a model car, and it's made so that 1 centimeter on the model represents 40 centimeters in real life. So first question, if the real car is 450 centimeters long, or 4.5 meters, how long would the model be? So much like we did with a map, we're going to set up a proportion, and I need to decide what I'm going to compare on the top versus what I'm going to put on the bottom. So I think I'm going to compare the model to the real car. So that means 1 centimeter on the model is 40 centimeters on the real car. Then in my second ratio, the information I have is about the real car. It's 450 centimeters long, so that would go on the bottom. And I'm looking for the corresponding length on the model. This might be a good time to use our cross products. So 40 times x should equal 450. Then I need to divide both sides by 40 to solve for x. And when I do that, I get 11.25. Now this is where it's going to be important to read the instructions on rounding. So for example, if there are no instructions, I would leave it as 11.25 centimeters for the model. If the instructions were to round to the nearest tenth, then 11.3 would be accurate rounding to round the 2 up to 3 because that is a 5. And the second question, if the windshield on the model is 3.8 centimeters long, how long is it in real life? So again, I'm going to use the same setup here where I put the model on top and the real car on the bottom. So same initial ratio of 1 centimeter to 40 centimeters. And the information I have here is about the model. So that's 3.8. And I want to know what that corresponds to in real life. So in this case, I can see that to get from a 1 to 3.8, I would have to multiply by 3.8. So I can multiply 40 by 3.8 as well. And when I do that, I get 152. So 152 centimeters in real life corresponds to 3.8 centimeters on the model. So a few things to remember. Always decide which quantity is going to be on the top and the bottom of your proportion. One side of your proportion or one of the ratios should always be the scale, and then fill in the information that you know on the other side.